Hello guys, welcome back to the video. So today we're going to see problem number 1792, maximum average pass ratio. So let's try to read and understand the problem first. There is a school that has classes of students and each class will be having a final exam. You are given a 2D integer array classes where classes of I equal to pass of I and total of I. You know beforehand that in ith class there are total students but only pass of I number of students will pass the exam. So we are given a 2D array classes where one information is how many student will pass and the other will be total students in it. Okay. So you are also given an integer extra students. There are another extra students, brilliant students that are guaranteed to pass the exam. Okay. And to pass the exam and are assigned to. You want to assign each of the extra students to a class in a way that maximizes the average pass ratio across all the classes. Okay, so they're telling we have a group of students and there we can add any student anywhere in that classes and they will pass. Definitely they will pass. Okay. So the pass ratio of a class is equal to the number of students of the class that will pass the exam divided by the total number of students. Okay, so they're telling the pass ratio will be suppose 1 and 2. So 1 is passing, there are total 2 students. So 1 by 2 is the pass ratio. Okay, the average pass ratio is the sum of the pass ratios of all the classes divided by the number of classes. So they are also telling there is average pass ratio when suppose this is for one class. So we take for 10 classes like this, add it and divide it by 10 again. So it will give us the average pass ratio. Okay. So pass ratio and average of all the pass ratios. It will be the that we have to find. So they're telling return the maximum possible average pass ratio after assigning the extra students. Okay. So after assigning these extra students, we have to find it. Okay. So we're given this example. Okay. 1, 2. So let's see in the board actually this example, the same example. We're given three classes 0, 1, and 2. Okay. One has having one passing student and total 2. Similarly, we have 3, 5, and 2, 2. So here everyone is passing. Okay. And we have extra students as 2. Okay. So let's make some write something and make some try to find it. See here I'm not showing you how to solve the problem. I'm showing you how to think and solve, like how you can get that solution. Okay, so let's write 1 by 2 first. Okay, here we'll write 3 by 5 and here we'll write 2 by 2. Okay, so let's see first 2 by 2. What happens if we add one student here? It will become 3 by 3. Does it make any difference? Because its ratio will be 1 only and here it will be 1 only. So I don't think adding any number of student to this one going to help us. So this class will just exclude as of now. Let's take these two classes. Okay, so here it is 1 by 2 and here it is 3 by 5. Let's try to add one class in it. Okay, one student in it. So it will be 2 by 3. And if we add it here, it will be 4 by 6. Okay, the ratio will definitely change here. Yes, so let's see how much it is changing. Okay, so if we take this ratio and minus this ratio from that, if we take this ratio and minus it from that, we'll get 2 by 3 minus 1 by 2 equal to 1 by 6. I just did a LCM 3 to the 6 and 2 minus 1 1 6. So similarly we'll do for this also. 4 by 6 minus 3 by 5 equal to 630. Okay, and 1. So we got the difference of the ratio if we add 1 1 to each. Okay, so which one is bigger? According to me, this one is bigger. Okay, 1 by 6. 1 by 30 is smaller than 1 by 6. Okay, so what we have to do, just think it, we have to maximize the average. Okay, so how are we going to maximize it? Just by adding the students. Okay, so if we add student in this, we're getting a less increased portion, but if we add to this one, we're getting a bigger difference. Correct? So what we'll do, we'll always add to the bigger difference. Okay. So in this way, now you can just think about it for 2 minutes and see, okay, I got it. So wherever the impact is more, wherever I'm getting the difference is more, I will add one student there. Correct? True. So we'll just adding it here. Now it will become 1 and 1 by 6 and whatever it happened. Okay. I'll just erase this and we'll try to do an iteration over this. Okay. Iteration for this here. Okay. Initially we have 1 by 2. Okay. So the impact if we add it, we'll just writing 2 by 3 minus 1 by 2, okay, equal to 1 by 6. Okay, this is 1 by 6, and here also we have something like 4 by 6 minus 3 by 5. This is 1 by 30. Okay, the impact is more here, so we'll just change this. Okay, so here our first iteration is done. We will just cut the student, make it 1. Okay, we have added 1 here. Okay, so now it will be 2 by 3 because we added 1 in both. So passing student will increase and total student will also increase, like that. And here it will be same only, nothing changes. It will come like this only, it will be 1 by 30. And let's find now, if we add here 1 and here 1, what will happen? If we add here 1, it will be 1 by 30 only. So let's try to find it here. It's 2 by 3 now. If we are adding 1, it will be 3 by 4. Okay, minus 4 3s are 12 and 3 minus 2 1. So still this one is greater, right? The impact will be greater. So we again add here. So its final component will be 3 by 4, sorry, 3 by 4. This is nothing, please ignore. Okay, so our final array will become this 3 by 4, this 3 by 5 only, because we have made no changes because impact was less and we have only 2 students. So now we are left with 0. We added both student in this one. Okay, and then we do the addition and took the average. So that's the simple part, but the main part was this identifying this logic. Okay, we have to add that student where we have to add it. So wherever it is making the more impact, we are adding there. So it's like that. So hope now the concept is clear. You can pause the video here and try to go and code it now, or else I will code for you. You can follow me with the video. Okay, so let's go there and try to write some code. Okay, so as we need the maximum difference at every time, like how we can maintain that maximum difference? We cannot just go and find every time, right? So for this we can use a priority queue, like a max heap. So it will always give us the maximum element, means the maximum difference we can get maximum impact, that element it will give. Okay, that class it will give, I can say. So let's write it. So we'll take double here because our return type is double and we are dealing in averages, correct? PQ equal to new priority queue. Okay. Then what we have to do, we have to find the maximum one. So we have to sort this in the reverse order. How we can do that? We can do that A comma B. We are taking an integer of double, means array of double here. We'll just need to write this double not compare B of 0 with A of 0. So this will give us the maximum at the top every time. Okay, this part is clear. So now let's try to include all the classes in this priority queue. Okay, we're going to iterate through all the classes and include that in the priority queue with the impact, the change that we can make by adding one student. Okay, so here we'll take again double pass equal to classes of 0 and 0. Okay, this is the passing student, correct? Then again we'll make a double total equal to, just copying it, I'm a little lazy to write. Okay, double total, then we'll see double change. What will be the change here? Okay, so double change will be, I'll show you, pass plus 1 by total plus 1. So this is our ratio when we add 1, and we will do a subtraction with the original ratio that we did in the board. We saw that, correct? Just remove this one. So we are just adding one student and seeing the difference, the change in that. And we'll just simply add it. We're not doing anything here. We'll just add it. New double. Okay. Change. Change we are writing first because we are here we have written right. On the basis of this change, we are doing the sorting. So maximum change we want up. Pass, comma, total. Okay. This we are adding so that we can update it and have the updated version instead of adding in the classes directly. Instead of changing the things here, we are doing here only. Okay. Now we will add the students. So while extra students is greater than 0. Okay, got it. So we'll keep on decreasing the students. Okay, and before that we'll do some operations. We'll take the top element as I told you, current equal to pq dot pull. We got the top element. We'll again do the steps. Okay, we'll add one thing. I'll show you. So in the pass, instead of this, we'll get current of 0, and in this top element we are adding one student. In this total also we are adding. Okay, current of 2 plus 1. Here not 0, it will come 1. Okay, and then again we will calculate the change. If we change one element, one student we add, and how must be the change, how will be the change, we are just seeing that part and just adding it back to the priority queue again. Okay, so this will make the changes what need to be done. It will increase the student in that classes. Okay, now we just need to calculate back the average and return. So I will take double sum equal to 0 while pq dot is empty, pty pq dot is empty. I'm going to add sum plus equal to. Okay, we'll take first double current again. We'll do a pull here. Okay, then current of 1 by current of 2. So this current of 1 by current of 2 is like pass by total in that class. We'll just adding it and we need to average this. So we'll return sum by classes dot length. Okay. Okay. Hope the code is clear. I'll just once go through it for you guys. Making a priority queue. In that we are storing what change, pass and total. So this will give us the maximum change every time, the maximum change in class if we add one student. Okay, then we are creating, means we are adding what is previously given to us in that priority queue. Then we are adding the students and adding the same element with that extra student in inside bag, and the change also we are calculating simultaneously. Then after doing this, we got a priority queue with the updated students, means the extra students are also added in it. We are just doing a sum and then returning the average. Okay, let's try to run it. Okay, I think, okay, this is dot length. Anything else you can see? No. So there are small mistakes actually. PQ dot pull. Hmm, cannot be converted to double. Okay, incompatible type. Oh, sorry, I forgot to add the array here. Let me check all the things. Okay, I think it's because of that only, most probably. Here also we need to add it. Okay, so these are some syntax errors that you should avoid. Okay, it's working fine. Let's try to submit it. Okay, it worked. So let's try to analyze and find the time complexity. So first we have a priority queue. So it will take log n time, okay? Log n time to sort the things. Then we have one loop, this one and this one. All are running for n times only, okay? So it will be big of n. So the combined complexity, time complexity will be n of log n, okay? And the space complexity will be big of n only, because we are just using a priority queue. So here n is the length of the class, means total number of rows or the classes in the we are given. Okay, hope you like the video. Hope you find it useful. If you have any doubt, please comment down. I will try to help you. Thank you.